Got that on the recording. All right, awesome. Yep, it's going online. All right. We all know who it is. All right, anyway, number 1. All right, enough with the gazoo. Let's put it in your bag for now. All right, number 1. C is the center of the circle. If segment AB is tangent to C, what must be true about segment AB and segment BC? So it's not saying that it is tangent, it's saying if it was tangent, what has to be true about these two segments. So what's true, if that's a tangent, would be true about those two segments? They'd have to be perpendicular. So if this was a tangent, then these would have to be perpendicular. So the first question's answer is AB would be perpendicular to BC. Now, the second question wants us to see, is it actually a tangent? So they give us the measures of all the sides of this triangle. And using all those measurements, they want us to prove that we do have a tangent. How can we prove that it's tangent? So now we can use Pythagorean theorem. Now, you can either use Pythagorean theorem, or if you know your properties of your Pythagorean triples, which ones they are, you could use that here as well. Because notice, you have 10, 24, and 26. They're all whole numbers. If they're all whole numbers, they'd have to be a Pythagorean triple in order to work for Pythagorean theorem, right? So, in this case, those are one of our Pythagorean triples. It's our 5, 12, 13 doubled. So if you recognized it as the Pythagorean triple, the 5, 12, 13 doubled, you could come out and say right now, yes, it is tangent because this is a right triangle. All right? If you don't recognize the fact that it's a Pythagorean triple, then you have to use Pythagorean theorem. So we'd plug in 26 squared is equal to 10 squared plus 24 squared, which would then be 676 is equal to 100 plus 576. 100 and 576 also gives you 676. So they are equal. Since they're equal, it is a right triangle. So, yes, AB is tangent because, it's a right triangle. Right. And that would be an acceptable answer. Number 2. This one, there's more than one way you can solve. So AC is drawn in for us already. Some people chose to draw in CB, since if I drew in CB, CB and CA are both radii, they'd be the same length. So if you drew in CB, you could solve for CB. All the measurements are already there for the legs. You'd just be finding your hypotenuse, so you'd have to use Pythagorean theorem. Or AC is already drawn for you, so you could just label the other half of AF as also being 14, because those two pieces have to be congruent. So we have a right triangle either way, and we have our two legs are 5.5 and 14. Now, you can't use a triple here. Are these for tomorrow's testing? Yeah. All right, thank you. No. I'll have to figure that out. Okay. On where was I? Number 7. So again, if that's 14, this has to be 14. So we have the two legs of the right triangle. We're plugging into Pythagorean theorem. So we have c squared. So this would be my c value. C squared equals a squared, 5.5 squared, plus 14 squared. 5.5 squared is 30.25. 14 squared is 196. Add them together, and you get 226.25. You got to take the square root, and it'll be approximately 15.04. And that'll be our answer. Number 3. Segment DE and segment FE are both tangents. Well, since we know those are tangents, we can automatically label those as being congruent. Two tangents coming from the same exterior point to their points of tangency must be congruent. So if we know those are congruent, we know that these are equal to one another. So we set them equal. 5x plus 10 equals 2x plus 14. And I wrote the wrong thing there. That says minus 10. So 5x, that should have been minus 10, not plus 10. So now, solve this. Subtract the 2x, bring it over to this side, you get 3x. Add the 10x to the other side, you get 24. Divide by 3, and x is 8. Is that our answer? No. What they ask us to find? DE. So, in order to find DE, we have to take that value and plug it back in. Don't forget to do that step. 5 times 8 minus 10. Could I have plugged in for the other side as well? Yeah, because they're equal, right? So, 5 times 8 is 40. 40 minus 10 is 30. That's our answer. Good. Number 4. We have these two chords are congruent, therefore the two arcs they intercept are congruent. So if that's 99, this is 99. So that's the first angle we're finding. The second angle, well, in order to get that piece, we know all three of the other arcs. Sorry, I said angle, I meant arc. That arc is 99. So now, this other arc would be 360 minus the 3 that we know. So 360 minus 99 plus 99 plus 37, which is 235. So 360 minus 235 is 125. That's 125 degrees for this other arc. All right, down here on the bottom, each one of these was slightly different. Now, 10 you could have done a couple different ways. Since they drew in the radii, I actually think it's easier just to see, hey, there is a quadrilateral there. Everybody see the quadrilateral? So, because this is a quadrilateral, I'm going to highlight it. In case you don't see it, there's the quadrilateral, right? And this is a right angle, and this is a right angle. Because this is a tangent, and that's a radius. That's a tangent, and that's a radius. So they meet at right angles. Since we have a quadrilateral, and we know 3 angles in a quadrilateral, an easy way to do this would be to just subtract the 3 angles from 360. So we can do 360 minus, again, we have 90, and the 90, and 161. Give us 19. The other way that you could have done this is, there's a second way, so I'm going to do that in blue. This arc is also 161, right? If you subtracted that from 360, you'd know the arc on the other side. 360 minus 161 is 199. You could do the difference of the bigger arc minus the smaller arc divided by 2, because this angle is on the outside of the circle. So if you did 199 minus 161 divided by 2, you also get 19. Again, both ways work. All right. All right, so then, number, 6. Number 6, the angle is an inscribed angle. This is its intercepted arc. The angle is half the intercepted arc, or the arc is double the angle. So if that's 32, this is 64. Not a whole lot of math to do there. Number 7, we have an inscribed angle again. Intercepting an arc. Well, the inscribed angle is half its intercepted arc. So divide that by 2 and you get 53. That's our answer. On number 8, there's multiple ways you can do this one as well. So, first method, we know that this whole thing that I'm highlighting in red is 180, right? If that's 180, subtract 132 from 180 and you're left with 48. If that arc's 48 and this angle is intercepting that arc, this is half of it, so this is 24. Now, The other thing that you could have done is this angle is inscribed into a semicircle. Therefore, this is a right angle. Could have also said that half of this would give you this angle, which would be 66. And then subtract 66 from 90 to get the other angle of the other acute angle of the right triangle, which is also 24. So again, two different ways that you can do the same problem. With these circle problems, on a lot of them, there are multiple ways depending on which property you use. Some will be longer than others. So, number 9. This one, again, we have two chords intersecting on the interior of a circle. We are given the measure of one of those angles. These two are vertical angles. Again, those two vertical angle measures are equal to the sum of their two intercepted arcs divided by 2. So 61 is equal to m plus 76 divided by 2. So first, multiply 2 to the other side. That's 122 equals m plus 76. Subtract 176, and you're left with 48. No, sorry, 46, not 48. And this one here was 24. Yeah.
Why, if we know that the other angle is 61, why wouldn't we just multiply by 2? And that's m.
It's not an inscribed angle. An inscribed angle is an angle that's on, it has to be on the circle, right? This is an angle that's on the interior of the circle. Let's see, do I have that note sheet handy? Here we go. So I posted this on Edsby. I did this during tutoring, but again, there's a difference whether it's on the circle. If it's on the circle, it's half the intercepted arc. If it's on the inside of the circle, this is the equation that we're using, right? The two arcs added together divided by 2. So that's... I redid them in tutoring. I posted them. I posted a video for it on Edsby. But again, we did the same notes. I just grouped them differently on here. All right. Number 10. Opposite angles of a quadrilateral inscribed into a semicircle are supplementary. So 180 minus 145 is 35. And that's it.
Wait, what did you say? 180 minus what? Go back.
180 minus 145. Because again, opposite angles of an inscribed quadrilateral to a circle is supplementary. So 180 minus 45 gives us 35. All right, next. On the back, number 11. We have these two arcs are both given to us. The angle is on the outside of the circle. So this is where we do the difference of the two arcs divided by 2. So m equals 204 minus 62 divided by 2. 204 minus 62 is going to give us 142. 142 divided by 2 is 71. And that's our answer. On 12, you can use the same exact formula. So if we know this arc is going to be this one subtracted from 360. So subtract this from 360 and you get 96. So then the measure of the angle is going to be equal to 264 minus 96 divided by 2. Subtract, you get 168. 168 divided by 2 is 84. So 84 degrees. On 13. This one, you can do this one a couple different ways. All right, we have this arc here is 140. So then for this angle, it's intercepting that arc, so it's going to be half of that intercepted arc, which would be 70. But that's not the angle they want. They want this angle. So then take the 70 and subtract it from 180 to get the one that makes a linear pair with it, and it's 110. So 110 is our answer. Now, could you have also found this arc first instead? Yeah. We could have taken the 140, subtracted it from 360, and been left with 220. And then did half of that one and got 110. You get the same answer either way. Number 14. This is the arc that is being given to you. That whole arc is 285. They want this angle. They want this angle. And that angle intercepts this arc. So this is 285. Subtract that from 360 and you get 75. Half of 75 is 37.5. That's our answer. Yeah, so again, this arc that I did in red is 285. Then in order to get the other arc, I did 360 minus 285. That gave me 75 for this arc. This is an inscribed angle. The inscribed angle is half of its intercepted arc. So divide in half, and you get 37.5. On number 15 and 17. Now, 15 and 17, I'm going to put a line through. I'm going to go back and do them, but those two, again, are not on the test. All right? Again, those are the two that I showed you guys how to do. I gave you the information, but when we did the notes, I said not important, right? I'll go back and show you how to do them. But again, you won't see those two on the test. Let's go over to 16. Again, we're going to do all the rest, and then I'll come back to those two. On 16, we have two chords intersecting. Those two chords that intersect, they're not perpendicular. All right. Again, what's happening here is the product of the two parts of one chord equals the product of the two parts of the other chord. So we're looking for this piece here. I'm going to call it x. So 7 times x is equal to 5 times 9. So 7x equals 45. Divide by 7 and you get a decimal, but the directions say round to the nearest hundredth. So this would be 6.43. That would be your answer. On number 18, they tell you find x. Well, these are two tangents. The two tangents coming from the same exterior point have to be equal. So 6x plus 2 equals 9x minus 7. Bring the 6x over, you get 3x. Bring the 7 over this way, you get 9. Divide by 3, and x is 3. And that's your answer. Don't have to plug back in this time. They just wanted x. Number 19. They said ST, this entire length, is 15. They also told us these two are the same length from the center, same distance from the center. Therefore, this one's also 15. Well, what do we know about these lines coming from the center? They're perpendicular bisectors. So all these pieces are 7.5. And we're trying to find MP, which was one of those sections. So it is 7.5. On the last one, they tell us that these two shapes are tangent to one another. Therefore, these two are going to be congruent. These two will be congruent. These two will be congruent. And these two will be congruent. So then they give us some measurements. They say AC, its entire length, is 10. They tell us this piece is 3. They tell us that this piece is 4. They tell us that this piece is 2. Well, if that's 2, this is 2. If that's 4, this is 4. If that's 3, this is 3. If that's 3 and this whole side is 10, then 10 minus 3 gives you 7. So then this is also 7. Now you can either add up all the little numbers to get the perimeter, or you can combine these and add up the big numbers. So this side would be 7, this side would be 6, this side would be 9. Add them up, and you get 32. All right, again, you have each one. I guess he's getting help over there. Never mind. I was going to explain it again, but he's not paying attention to me. It's all right. You know. Number. I just like how he asks the question and then pays no attention to me, though.
Hey.
No, it's all right. It's all right. He's got it. He's got it down. All right. On 15 and 17. These two came from the formula that I gave you on the worksheet from our notes last week. Now, I said it wasn't important. Oh, wait. Was it last week? No, 2 weeks ago. 2 weeks ago. So, again, the exterior times the whole equals the exterior times the whole. All right? So, exterior here is 10. The whole... Well, I want this piece, is what we're finding, so the whole is going to be 10 plus x. Here, that's 8. The whole would be 19. So if I was setting this problem up, I'd have, guys, I'd have the exterior is 10, times the whole is 10 plus x. On the other side, the exterior is 11, the whole is 19. So, 10 times 10 is 100, plus 10x equals 11 times 19, which is 209. Subtract the 100, have 109. Divide by 10, and you'd have 10.9. On 17, it's the same formula, but this side's tangent, so the exterior and whole is the same, so it's the tangent squared. So we have the exterior is 4, the whole thing is 14. So we'd have 4 times 14 equals the tangent, which is what we're trying to find, squared. So, 4 times 14 is 56. The square root of 56 is either 2 radical 14, or, since it said round to the nearest whole number, round to the nearest hundredth, 7.48. And that'd be it. Alright? So again, that's the whole review. Again, the test itself, there is 19 questions, out of which 16 are exactly like this review, and the other 3 are all vocab. Alright? You got a question?